Okay, lab number 1 for the UT2 set of labs, we're going to make an electronic DAC. Okay, so get our scope hooked up, get our transducer hooked up, turned on, set at about 43 dB gain, got a range of about 7 inches, so on and so forth here. We want to know if we're going to use these blocks right down here to do an actual DAC. We want to know what we're doing, how we're doing it, so on and so forth. Okay, so if I just get this first block here, this is telling us it's ASTM E127. That's the standard that they made this block to. But on the back side here we have 7075 50075. That stands for 7075 stands for aluminum, 5 stands for 564 size defect, and this tells us how deep the defect is. Okay, the block itself's not that thick. It's probably only 2 inches or so thick. Okay, maybe 1.5 inches, but that 75 tells us that the defect was drilled 3/4 of an inch from the top of the part. Okay, so let's get the glare off here. Back up a little bit. Back the scope up. Get these blocks a little bit more in line. Okay, so we want to set our range to the back of this thick block for our DAC. Okay, because with the DAC, we're only going to be able to inspect whatever this tallest range is, which it winds up being about 3 3/4 of an inch. So we want to set our range to 4 inches. Okay, and it's aluminum, so we'll take that out to aluminum, about 250, which it might not be exactly 250. We can fine tune that here in a minute. And then we want to bring our delay back to 0. This thing jumps, as you can well see. Okay, so then go to our pulsar. We got low damping, high damping. That cleans that up quite a bit. We got high power, duals off. Go to receiver. Let's look and see what gives us our cleanest signal here. 0.8 to 8 gives us our best signal, it looks like. So we'll stick with that. Okay, go back to here. We want to put this signal, a little coupling down here. We're going to set our back wall, like I said, to the height of this part here. So we're going to take our range, roll it down, and it looks like here telling us about 3.837. I measured it and I know it's 3.750. So we're going to set our range to 3.750, and we're going to adjust our velocity to clear up the difference. So it goes down to about 243.8. That's not a big deal. So if we wanted to tell the thickness of this first block, which is part of what I want you guys to find out, thickness of the first block here is about 41% of 3.75. Thickness of the second block is about 60% of 3.75, and then 100% of 3.75. You don't really need to find that out, but anyway, thickness of the first block, thickness of the second block, thickness of the third block. Anyway, the defects here are in the center, right in the center of this part. So here's our front wall at least. I'm going to scan over the center of that. Alright, and you see that signal pop up right past 20%, right at about 22%. So we want to peak that signal up kind of as high as we can get it. Alright, and a DAC, a distance amplitude correction, is going to tell us if we have a 5/64 defect in this thickness of material, this 3.75, that 5/64 defect should break a gate, should be a reject criteria, saying anything bigger than 5/64 of an inch should give us a reject signal. So we're going to use this gate to kind of help us out to do that. So I'm going to get us to DAC here. Alright, DAC. We're going to turn the DAC on. Okay, there it is. Now we want to bring this first signal for our reject criteria up to 80%. Okay, or as close to 80% as we can get it. So, take my gate, roll it over the front, or roll it over that signal I should say, and then push the grab echo button, and you see it put a red line across there. Okay? So now we go to our next part. Peak that defect up. Okay, now granted, because of attenuation, you're not going to get the signal up to 80%. Part is thicker, got attenuation to deal with, so on and so forth. So we peak that signal up about as high as we can get it. And it might not be perfect, we're going kind of quick here. Okay, hit this button again, and it says echo is out of range. Okay, that means we need to put the gate over the top of it because it doesn't know where we're telling it to go. So put the echo over the, or put the gate over the echo. Alright, there we go. Hit it again, come over here to our thick part and find that defect, which there it is. We're going to peak it up as much as possible. Run it up to 80%. Roll the gate over the top of it. Hit take echo. Bring our gain back down. You can see the red line coming down across the screen there. Set this first one at 80. So now we can say, alright, there's our back wall. If we scan 3.75 inch material all day long, a 5/64 defect gives that response. Okay? So there's our defect at 3.75. Actually, what we want to know is 80% of 3.75 makes the defect be how deep. Okay, there's our next thickness. Okay, I should say our middle thickness, which was 60% of 3.75 inches. There's our defect popping right up to the gate. And like I said, if any defect was larger than that, it should push through that gate. So we can try that out here. Let me peek this up to make sure we're pretty close to our 80% screen height, which we are. We're not necessarily perfect, but we're close enough. And get this thing to peek up back where it was. There it was. There we go, right at 80% there, just where we set it. So now let's go to our middle block and go to an 8/64 defect. Okay? Or our end block, I guess. Same part, looks the same. Instead of being 5/64 defect, it's 8/64 defect. So, should be the same depth. We should be able to see that signal peak up past. Okay, so there's our signal on an 8/64 defect, and there it is. We just run right over the top of that signal. 8/64, bigger than 5/64, bigger signal. Okay, so let's kind of zoom in so you can see that there. There you go. Let's go back to our 5/64. Okay, go to this block over here, put our signal on there, peak it up as much as possible, right in the center of the block. There it is. Come back down a little bit, and that's it. That's our signal. Doesn't pass the gate. So here's our block one last time. Come back over here, and then real quickly, that signal jumps right through the gate. Alright, so your question there is, how thick were the blocks, and then what is a DAC used for? Distance, amplitude, curve, or correction used for? Give you a second to kind of soak that up.